Welcome students, welcome to the video class. Today we will discuss geomagnetism or terrestrial magnetism. Okay, so what is this terrestrial magnetism? So it is a branch of physics which deals with the study of magnetism is called terrestrial magnetism. Again, the branch of physics which deals with the study of earth magnetism is called terrestrial magnetism. ठीक है. तो let us consider a bar magnet. ताको यदि हम freely suspend करिबा तो what happens? So it always, if you see, यदि हमें गोटे bar magnet को freely suspend करिबा, we always see that it align itself along north south direction. Again, it align itself along north south direction. Why? So reason is I am discuss भी करिथिले. When you consider earth, so as per the geometry of this earth, this is called geometrical north. This position is called geometrical north. Similarly, this position is geometrical south. Geometrical north, geometrical south. Earth itself is a huge magnet. Earth itself is a huge magnet. तो यदि ह्यूज मैग्नेट अछि तार नॉर्थ पोल थिबो साउथ पोल थिबो द नॉर्थ पोल ऑफ दिस अर्थ magnet lies at geometrical south. Again I am saying sorry, this south pole of this earth magnet lies in geometrical north. Again, the south pole of this earth magnet lies at geometrical north of earth, and the north pole of this earth magnet lies at geometrical south. That's why whenever we place a compass or this freely suspend a bar magnet, it align itself along. Let us say this is a compass. So there north thibo, this is south. The north of this compass will be attracted towards the south of this earth magnet, and the south will be attracted towards the north. So that's why she rotate heiki, it always remain in this north south direction. North south direction. Same is the case in this bar magnet. So जब freely suspend करिवा, this north pole will be attracted to the south pole of this earth magnet, and the south pole will be attracted towards the north pole of earth magnet. That's why it always remain in north south direction. बुझलो? But this is not the truth, total truth. यदि हमें consider करिवा this earth and earth magnet, because earth is a huge magnet, so सेटा को earth magnet भी कहि पारे. So if you consider this earth, so this is the geometrical north, this is the geometrical south. Earth magnet, earth which is a huge magnet, it slightly टिके कोन हेतो bend हे गयो. It is slightly bend, टिके bend हे गयो. At around this is 23.5 degree with respect to this line passing through this geometrical north and geometrical south. Again, the earth magnet, so it is tomorrow south, this is your north. The earth magnet slightly tilted to the line passing through this geometrical north and geometrical south at around this 23 degree. That means it is slightly tilted with respect to the line passing through geometrical north and geometrical south. When you consider the earth, so this is the geometrical north and this is the geometrical south as per the geometry of earth. Okay, The line passing through this geometrical north and geometrical south is called geographical axis. Again I am saying the line passing through the geographical north and geographical south. This is called geographical axis. Along this axis the earth rotates itself. The rotate itself. ठीक है? And I will just discuss कले the earth टिके tilt ହେଇକି ଅଛି. So this is the south. This is the south pole of earth magnet and this is the north pole of earth magnet. ठीक है? And the line passing through this the line passing through north and south pole of the earth magnet is called magnetic axis. Again, the line passing through the north pole and south pole of earth magnet is called magnetic axis. It is called magnetic axis. And the great circle, plane the great circle which is perpendicular to this magnetic axis is called magnetic equator. Again, the great circle, because it's a circle, earth ta gote circle, तो जदि हमें earth को sorry ये जो plane को consider करिया तो ये जो circle टा pass करूची along this plane, that is called this magnetic equator. That is called the magnetic equator. It is perpendicular to this magnetic axis. ठीक है? And हमें जो देखिए this since earth is a magnet itself, so these are the field lines. These are the field lines. It starts from the north pole of earth magnet and ends in the south pole. ठीक है? Next is magnetic meridian and geographical meridian. ठीक है? So we have taken, this is the earth and this is the geographical axis and this is the earth magnet and this is the magnetic axis. ठीक है? So the plane passing through geographical axis is called geographical meridian. ठीक है? And the plane which is passing through magnetic axis of the earth magnet is called magnetic meridian. Okay, again, the plane which is passing through magnetic axis, sorry, geographical axis is called geographical meridian, and the plane which is passing through, that is magnetic axis, is called magnetic meridian. And this is shown in this figure also, because our magnetic axis is bend. So this plane is called, this is your magnetic meridian of earth, and this plane which is passing through the geographical axis is called geographical meridian. This is shown in this figure. Definition पढ़ दो. The vertical plane passing through the magnetic axis of a freely suspended small magnet is called magnetic axis. एटा को एमती डिफाइन कर परिया. So let us consider a freely suspended bar magnet or magnet. Bar magnet ना. So this is the north, this is the south. तो magnetic axis कौन this? So the plane which is passing through the magnetic axis of this small magnet is called this magnetic meridian. And the earth magnetic field act along the direction of this magnetic meridian. We just go here. So this is the magnetic meridian, and if this is the magnetic meridian and this is the earth magnet, so earth magnetic field is like this. Inside of you, that is from south through north. So the earth magnetic field act along the direction of this magnetic meridian. Along this corner, that is south through north, inside. Okay. Next is geographical meridian. Define correctly. The vertical plane passing through the geographical north and south. The vertical plane passing through the geographical north and south of earth is called geographical meridian, which is shown in this figure also. ठीक है जी? Next is magnetic elements of Earth. Okay, so what are the magnetic elements? To determine the magnetic field at any place, we need three parameters. Again, to determine magnetic field at any place, we need three parameters. They are, that is declination, it is represented by this alpha. Second is inclination, or dip भी कुहाଯାଏ, it is represented by this delta. And third is horizontal component of Earth magnetic field. ठीक है? Okay. So first we will discuss what is declination, that is alpha. तो हमें जानिए कि the plane that is passing through geographical axis is called geographical meridian, and the plane that is passing through magnetic axis is called magnetic meridian. The angle between this magnetic meridian and this geographical meridian is called this declination, that is alpha. Again, the angle between this magnetic meridian and this geographical meridian is called this declination, that is alpha. ठीक है? So these are the two planes. ताकू जो केमती रिप्रेजेंट कर एमती भी रिप्रेजेंट करा जाए. This is the first plane and this is the second plane. The angle between them is alpha. एमती कोई परियो. If we say this is the magnet, take tilt take एमती हो. Again, if we say this is the magnet, एमती. This angle is called alpha. बुझ लो. Declination alpha at any point of the Earth is the angle between geographical meridian and magnetic meridian. ठीक है? Next is magnetic inclination, that is represented by this delta, or it is also called angle of dip. This angle of dip is important for your this exams. Short question हमारा से. ठीक है? तो we consider Earth is a huge magnet. Earth is a huge magnet. So when we consider Earth is a huge magnet, so it will have magnetic field around itself and it will produce magnetic field lines. So this diagram shows the field lines of this Earth magnet. The field lines are from North Pole and ends in the South Pole. Okay. So this diagram is important. So this diagram shows Earth and this Earth magnet. So this is the North Pole of this Earth magnet and this is the South Pole. And the magnetic field lines start from the North Pole and ends in the South Pole. So when you see this diagram, there is some angle between the field lines and the surface. Field lines and the Earth surface. This angle is called, this is magnetic inclination, or this delta or angle of dip. The angle between this is magnetic field lines and Earth surface is called, this is magnetic inclination. The angle between this magnetic field lines, let us say it is represented by this BE, and the horizontal ground level, that is Earth surface, is called angle of dip. Let us consider this. Let us consider this is the Earth. So let us say this is the Earth magnet. So if it is Earth magnet, the field lines start also from the North Pole, and it will be moving like this. Again it will go to the South Pole. Again, this like this. So that means at the poles the field lines are perpendicular to the Earth's surface. The field lines are perpendicular to the Earth's surface. So 90 degree. So we can say at poles this delta is 90 degree. Angle of dip is 90 degree. Like this it is moving, and at the equator, so it is parallel to the surface. This is your field line and this is the earth surface. So angle is 0 degree at the equator. So at the equator, this is the earth surface and it is the field lines. So angle kete 0 degree. So at equator delta is how much? 0 degree. Again when it reaches the south pole, the angle is 90 degree. The angle is 90 degree. ठीक है, पूछ लो. Again I am repeating, this is important. The angle between magnetic field lines of the earth magnet and the horizontal ground level, that is earth surface, is called magnetic inclination. Magnetic inclination, that is delta, or it is also called dip. बुझलो ना? So at different point it is having different angle when it is moving from north pole to south pole, like this. It will empty. So ठीक है. So that means at the poles the delta is 90 and the equator it is 0 degree. When you consider the earth magnet, so it is slightly tilted like this. And यदि हमें direction देखिएगा, the direction is from south to north. The net magnetic field strength direction is from south to north. This is also shown in this figure. So this is your net earth magnetic field strength. So it is making an angle. This is delta, that is your dip angle, with the horizontal direction of magnetic meridian. तो dip routing आपको definition भी कोई पर है. It is the angle between net earth magnetic field strength with the horizontal direction of this magnetic meridian, or that is horizontal ground level, or that is earth surface. ठीक है? Okay. এটা আউটসাইড থেকে বুঝিয়ে বলছে. So let us say this is the earth magnet. So when you say this is the earth magnet, এটা টিকে bend ହେଇକି. So that this जो angle করছে, this angle is called, that is alpha declination. এটা আমি discuss করেছিলে. This angle is called declination. ठीक है? So this is your alpha, that is declination. Again this টিকে bend, that is declination. এটা টিকে horizontal সହିତ angle করছে, that is your dip angle. Horizontal সହିତ কিছুটা angle করছে, that is your dip angle. Again this horizontal সହିତ जो angle করছে, that is your dip angle. ठीक है? This is your delta. Again this is your earth magnet. টিকে bend होছে, that is your alpha. টিকে bend होছে, that is your dip angle, that is delta. ठीक है? Okay. Next is component of earth magnetic field strength. Okay. So the net magnetic field strength of this earth magnet is making an angle delta with the horizontal direction of magnetic meridian. So it will have two components. One is horizontal component, second is vertical component. One is horizontal component and second is vertical component. So horizontal component कौन होगा? That is b cos theta. इटा b which इटा कौन होगा? Since it is the angle is delta, so we can say this is bh is b cos theta नहीं, that is b cos delta. this is b cos delta. So this is the horizontal component. Vertical component कौन हो? That is b sin delta. ठीक है. Okay. At the poles, delta is 0. Sorry, delta is 90. तो BH कहते हो तो BH is equal to that is B cos 90, that is 0. The horizontal component of Earth magnetic field strength at poles is 0. Equator रे delta कहते हो 0. तो BH कहते हो that is BH is equal that is B cos 0, that is B. ठीक है. Okay. So let us say this is equation 1. This equation 2. Squaring equation 1 and 2, what we get? This BV square plus BH square is equal to how much? That is B sin theta whole square plus B cos theta, sorry, theta नहीं, this is delta whole square. So that is equal to how much? That is B square sin square alpha cos, sorry, sin square delta cos square delta, that is sin square delta plus cos square delta. So that is how much? So this is B square and this is 1. So what is the relation? That is B square is equal to BV square plus BH square. ठीक है. So we can also write this B is equal to root over of BV square plus BH square. So the relation between net magnetic field strength of this earth magnet is equal to root over of BV square plus BH square. ठीक है. जब ये दिटा को divide करिबा 2 by 1 कौन आसीबो? We'll get 8 लिखि दो. That is BV by BH is equal to that is B sin delta by this is B cos delta. BB cut, so that is tan delta, or that is BV by BH. So we can say this is delta is equal to tan inverse BV by BH. Okay, A theta important for doing numericals. Again, this is that is dip angle is equal to tan inverse BV by BH, and this P is equal to BV square plus BH square of root over. ठीक है. Next we will do a question based on this horizontal and vertical component of Earth magnetic field strength. The question is, the horizontal component of Earth magnetic field at a place where the dip angle is 60 degree is 4 into 10 to the power minus 4 Tesla. Calculate the vertical component and the resultant field at that place. Again, the horizontal component of Earth magnetic field at a place where the dip angle is 60 degree is that is 4 into 10 to the power minus 4 Tesla. Again, the horizontal component of Earth magnetic field at a point where the dip angle is 60 degree is, ठीक है. Calculate the vertical component. So that is BH, that is B cos delta is equal to 4 into 10 to the power minus 4 Tesla. ठीक है. So that is, so B is how much? That is 4 into 10 to the power minus 4 divided by that is cos delta. So that is 4 into 10 to the power minus 4 divided by cos delta is 60. Cos 60 is half. So that is half means 2 tau crew padebo, so that is 8 into 10 to the power minus 4 Tesla. So that is net magnetic field strength is, that is 8 into 10 to the power minus 4 Tesla. Okay, next is horizontal component, sorry, vertical component. So BV is equal to, that is B, that is sine delta. So beta कहते हैं इसलिए 8 into 10 to the power minus 4. This is 8 into 10 to the power minus 4. Sine 60. So that is 8 into 10 to the power minus 4 into sine 60 is root 3 by 2. Okay. So that is how much? That is 4 root 3 into 10 to the power minus 4 Tesla. So the vertical component is 4 root 3 into 10 to the power minus 4 Tesla, and the net magnetic field strength is 8 into 10 to the power minus 4 Tesla. ठीक है. Next is neutral point. Neutral point. So what is a neutral point? So it is a point where the magnetic field due to a magnet is equal and opposite to the horizontal component of Earth's magnetic field. So it is a point where the magnetic field due to a magnet is equal and opposite to the horizontal component of Earth's magnetic field. So Earth is a magnetic field. Sorry, Earth is a magnet. It will produce its magnetic field lines. Magnetic field line जेतोळे create करूची, तो inside it is from south through north, बाहरे from north through south. Again भितरे south through north. ठीक है. So let us consider two cases. In the first case, north pole of Earth magnet pointing north of this bar magnet. ठीक है. Let us consider a bar magnet placed in the magnetic field of this Earth magnet. The bar magnet will also produce its own magnetic field lines, just like this Earth magnet. ठीक है. So case one is the north pole of this Earth magnet is pointing to the north pole of this bar magnet. ठीक है. तो this is the north and this is the south. So magnetic field lines कौन हो from south through north of Earth, south through north of Earth magnetic field. And यदि हमें बार magnet को consider करिया, the magnetic field lines inside होगा south through north, बाहर कौन होगा, that is from north through south. So if you see these lines and these lines, they are in same direction. The magnetic field lines of Earth and the magnetic field lines of the magnet is in same direction. It is the same. Kintu if you see this line or this equatorial line of this bar magnet, a point jagare kono, the magnetic field lines of the bar magnet is opposite to the direction of magnetic field of Earth. ठीक है. तो the neutral point will lie in this direction, sorry, in this line, equatorial line. Just let us consider this point. So a point रे, that is magnetic field line of this bar magnet is in this direction. Earth magnet in opposite direction. If the two magnitude are same, then it is a neutral point having zero magnetic field strength. ठीक है. So we can say this P is a neutral point. Similarly, this Q is also a neutral point where the net magnetic field strength is 0. Which this P and Q lies along the equatorial line of this of this bar magnet. Next is this case 2, south pole of Earth magnet pointing to the north of this bar magnet. ठीक है. So if you see this bar magnetic field lines from north to south outside. So Earth magnet that is from south through north. that is in this direction, this it was same thing. So if you see this equatorial line, तो बार मैग्नेट ऑफ फील्ड लाइन जो पटे एर्थ मैग्नेट ऑफ फील्ड लाइन से पटे तो सेम डायरेक्शन होचंती तो नो न्यूट्रल पॉइंट. बट इफ यू सी these points, let us say this point, तो एठी earth magnet direction is upward, bar magnet of field lines is downward, so they are in opposite direction. So if at this point the magnitude of magnetic field strength of this bar magnet and earth magnet is equal and they are in opposite direction, so they will cancel each other. So that means P is a neutral point. Similarly, Q the same thing. Bar magnet direction is downward, earth magnet upward. So that means opposite direction. यदि दीटा का मैग्नीट्यूड समान थे तो Q is a neutral point. That means this neutral point lies along the axial line of this bar magnet. ठीक है. Next is hysteresis. Okay. So we will read this hysteresis loss in transformer. ଯେତେବେଳେ ଆମେ AC ट्रांसफॉर्मर पढ़िबा तो सेतବେଳେ हमर आसो दैट इज हिस्टेरेसिस लॉस. ठीक अछि. तो हम फर्स्ट बुझे व्हाट इज हिस्टेरेसिस एंड आफ्टर दैट AC रे हम बुझ परिबा हिस्टेरेसिस लॉस कोन. तो लेट अस कंसीडर ए external magnetic field having magnetic intensity that is H. ठीक है. तो in that magnetizing field, let us place a ferromagnetic substance. Let us place a ferromagnetic substance. Ferromagnetic substances are strongly attracted by the external magnetic field. They are magnetized along the direction of external magnetic field. ठीक है. तो ताकू यदि आमे external magnetic field रखिबा तो all the dipoles that is present inside this ferromagnetic substance, it will be aligned along the direction of external magnetic field. That is called magnetic induction or magnetization. ठीक है. और that is सेतरे कोन हो, that is intensity of magnetization हो, and due to this poles ଆସିବ and after that pole जदि ଆସିला it will have its own magnetic field, that is magnetic induction. ठीक है. So let us consider this a ferromagnetic substance and place it in a external magnetic field having intensity H. So this is H and this is induction, magnetic induction inside this ferromagnetic substance. तो जेतବେଳେ ଆମେ ताको external magnetic field रखिबा तो धीरे धीरे कोन हो, जति H रो वैल्यू टा बढ़ी बढ़ी जिवो तो मैग्नेटाइजेशन भी बढ़ी बढ़ी जो और इंडक्शन भी बढ़ी बढ़ी जो. So it will move in this direction, in this path. H बढ़िबो, B मध्ये बढ़िबो. So that's why like this. Again this H बढ़ुची, B मध्ये बढ़ुची. It will move in this path till it reaches saturation point. Till it reaches, this is saturation point. Saturation point means at this point all the dipoles are aligned along the direction of external magnetic field, and this point, let us say this is H max. After that H रो वैल्यू यदि बढ़ेबा तो B रो वैल्यू बढ़िबो नाही. काहे कि because it has reached saturation point. ठीक है. ए पॉइंट परे तो let us decrease the value of H. यदि H रो वैल्यू डिक्रीज करिबा तो जति की इंडक्शन हेथिबो सेटा मते डिक्रीज करियो और इट इज कॉल्ड डीमैग्नेटाइजेशन. तो कोन होबो, दैट इज B रो वैल्यू मते बढ़ी कमी कमी जिवो. एटा कमिले एटा कोन होबो, कमियो. बट इट इज नॉट लाइक दैट. यदि हम H रो वैल्यू बढ़िबा कमेबा B रो वैल्यू कमियो किंतु सेते परिमाण रे नै. It will move in this path. H रो वैल्यू तो 0 होई जिवो इंडक्शन ता पाखरे किछिटा थिबो इंडक्शन टा जीरो हबो नाही तो किछिटा दिस मैग्नेटिक इंडक्शन रही जीवो इवन आफ्टर h टाइप जीरो हो और एक्सटर्नल मैग्नेटिक फील्ड को जीरो कर देले मथ्य ता पाखरे किछिटा इंडक्शन रही जीवो दिस मच वैल्यू दिस इज कॉल्ड रेसिडुअल मैग्नेटिज्म the that residual magnet it is the magnetism it remains inside this ferromagnetic substance even after the magnetizing field is removed the magnetic induction left behind in the sample after the magnetizing field is removed is called this is residual magnetism तो एतिकी परिमाण रे residual magnetism का पाखरे that ferromagnetic substance पाखरे रही जीवो को direction the direction is in this direction ठीक है जदि सपोज इफ आमे कोन करे ए पॉइंट रे दिस आमे ताकू एक्सटर्नल मैग्नेटिक फील्ड दवा इन दिस डायरेक्शन बट इंडक्शन ता पाखरे अछि कोन इन दिस डायरेक्शन तो एटा कोन धीरे धीरे जीरो हबो इफ यू इंक्रीज द वैल्यू ऑफ h जदि हम h रो वैल्यू ता बढ़ी बढ़ी नबा इन रिवर्स डायरेक्शन तो कोन हबो दैट इज जो रेसिडुअल मैग्नेटिज्म अछि इन दिस डायरेक्शन इट विल डिक्रीज तो ए पाथ रे से मूव करिवो तो एट दिस पॉइंट at this value of h all the residual magnetism becomes zero all the residual magnetism become zero at this value of h ठीक है so that is called coercivity ठीक है the value of reverse magnetism required for the residual magnetism required for this residual magnetism of the sample to become zero एटी होची b एटी कोन हला b रो वैल्यू 0 तो at this value of h the value of b is 0 तो this value of h is required in opposite direction to make this residual magnetism in this direction to become 0 that is called this coercivity the value of reverse magnetism required for the residual magnetism of the sample to become zero residual magnetism to become zero is called that is coercivity ठीक है ए पॉइंट रे कोन होबो at this point h रो वैल्यू थिबो and for this value all the residual magnetism become zero तापरे h रो वैल्यू जदी बढ़े नबा तो कोन होबो तो this ferromagnetic substance will be magnetized in this direction तो it will be magnetized in this direction तो धीरे धीरे कोन h रो वैल्यू जदी बढ़े नबा तो it will be magnetized in this direction in this path ठीक है h रो वैल्यू जते बढ़े नबा मैग्नेटाइजेशन हो इन ऑपोजिट डायरेक्शन तापरे h रो वैल्यू जदी कमेबा तो कोन होबो अगेन दिस डीमैग्नेटाइजेशन होबो एबे मैग्नेटाइजेशन को डायरेक्शन अछि इन दिस डायरेक्शन दिस इज द सैचुरेशन पॉइंट पर यदि h रो वैल्यू बढ़ले किछ होबन इट विल रिमेन सेम तो दिस इज h max इन ऑपोजिट डायरेक्शन h रो वैल्यू यदि कमे नबा तो कोन हो डीमैग्नेटाइजेशन तो b रो वैल्यू टा कोन हो कमे जिवो ठीक अछि दिस इज b इन ऑपोजिट डायरेक्शन तो b रो वैल्यू टा कोन हो कमे जिवो धीरे धीरे कमेओ h रो वैल्यू अधिका कमुची किंतु b रो वैल्यू सते कमुन ठीक है व्हेन इट तो ए पाथ रे से मूव करो दैट मींस व्हेन इट रीचेस हियर तो ए पॉइंट रे h रो वैल्यू 0 हे गेला किंतु ता पाखरे किछिटा रेसिडुअल मैग्नेटिज्म रहिबियो को डायरेक्शन इन दिस डायरेक्शन तो किछिटा रेसिडुअल मैग्नेटिज्म रहिजियो इन दिस डायरेक्शन ठीक है आफ्टर दैट जदि हमें ताकू h ए डायरेक्शन दबा तो ये रेसिडुअल मैग्नेटिज्म धीरे धीरे कोन हो 0 हो लाइक दिस एट दिस पॉइंट all the residual magnetism in this direction will become 0 at this point तापरे h रो वैल्यू यदि आउरी बढ़े नबा तो the ferromagnetic substance will be magnetized in this direction like this path ठीक है तो इनिशियली से एमती गला फेरिला बट इन अलग पाथ रे दिस इज फॉर फर्स्ट प्रथम जो मैग्नेटाइज हम ए पाथ फॉलो करिवो आफ्टर दैट इट विल मूव लाइक दिस ए पाथ फॉलो करिवो नाही ठीक है this graph shows the variation of B with H or it is a BH curve. So this H is equal to B by mu because B is equal to mu H, so H is equal to B by mu. So that is B square by that is mu. Okay. So when you find the unit of this B square by mu, this unit is equal to the unit of energy or volume. This unit is equal to the unit of energy per volume. ठीक है? So that means we can say this graph represents energy per volume during magnetization and demagnetization. Magnetization, let us say this is substance 80 or when H is 0, B is also equal to 0. So when H increases, B also increases. So this is magnetization. Then this is demagnetization till this point. At this point, this is the magnetized substance is demagnetized because B is equal to 0 here. Again it is magnetized, then it is demagnetized. Again it is magnetized. So let us say this first quadrant it is magnetized, second this is demagnetized. So यदि हमें कर्व करिया this is during magnetization, so this area represents energy or volume during magnetization or energy gained during magnetization. ठीक है? यदि A graph करिया from this point to this point, so this graph represents demagnetization. ठीक है? So this area represents energy lost during demagnetization. ठीक है? Energy gained during magnetization, energy lost during demagnetization. तो ये तीटा area जो देखिए, which area is more? This area is more. That means loss is more. Loss is more. So we can say this whole area represents energy lost during magnetization and demagnetization. हमें whole process को यदि देखिए, we can say the whole area represents, just like this first quadrant, represents energy lost during magnetization and demagnetization. This is also called hysteresis loss. Loss of energy or volume during this hysteresis. So what is this hysteresis? So the phenomena of lagging of magnetic induction behind the magnetizing field is called hysteresis. Meaning is यदि हमें B जो परिमाण रे दोछु, यदि हमें H जो परिमाण रे दबा, if induction सही परिमाण रे हबो, then we can say this is B is directly proportional to H, or this is graph over like this. किंतु एठी there is a lagging. काहे कि हमें एठी, if you see from this point to this point, हमें H कम दोछु किंतु B टा अधिक होछु. See this? From this point to this point, we are giving H this much, but B is more. Less B and more, less H, more B. Similarly, यदि A point देखिए, let us say this 80, this is H is more, B is less. ठीक है, तो there is a lagging between this is H and B during this magnetization demagnetization process. Again, there is a lagging between B and H during this magnetization and demagnetization process. This process is called hysteresis, and loss during this process is called hysteresis loss, जोटे कि हमें ट्रांसफॉर्मर में पढ़िबो. ठीक अछि. The phenomena of lagging of magnetic induction behind the magnetizing field is called hysteresis. ठीक अछि.